Awesome. Sorry about that, y'all. Next up, we have Dillon Mulroy here. He's going to be presenting a case study on adopting the effect at Vercel.
Yeah, thank you. Just as a quick poll here, does anybody know what effect TS is?
Oh yeah, baby.
We got three-ish. Okay.
What?
So admittedly, this talk was written for a conference next week in Italy called Effect Days. Galen called me about a month and a half, 2 months ago, or whenever it was, and was like, "When do you leave for Italy?" I said, "Saturday." He said, "Okay, you're going to be an RBA for this conference, giving your talk first." I said, "Okay." So I literally just finished my slides before this. This is kind of my first run through this, so bear with me. I appreciate the understanding. I'm going to try to adapt some of this to try to teach bits of effect along the way, but it is kind of geared to an audience that might be more familiar with what effect is. To give like a quick high-level summary of what I like to describe effect as is TypeScript's missing standard library. It brings a lot of things to the table that we generally are pulling in from NPM packages or creating ourselves and generally creating it poorly. So more specifically today, I want to talk about how Vercel has adopted effect on the domains team and our domains products. Who am I? I am Dillon Mulroy. I'm a software engineer. I've been doing this for 11 years, mostly working in TypeScript, React, Node, GraphQL, that whole world. I currently lead Vercel's domains product area and the engineering team. I've been using effects since its 3.0 release, which was kind of actually its 1.0 release. That came out last spring sometime, and like I've fallen in love with it. If you guys watched my talk at the last RDA conference, I was talking about compiling OCaml to JavaScript and talking kind of about how, you know, I was feeling burnt by certain properties and traits of TypeScript and how I felt it didn't entirely scale, not on a technical sense, but more at the organizational level as engineering orgs grow, teams grow, code bases grow. And effect has kind of reeled me back into the TypeScript ecosystem and given me like an appreciation for TypeScript, JavaScript, and building services with it. You can find me yapping on x.com pretty frequently. I stream every Monday through Friday, 7 a.m.-ish to 10 a.m.-ish doing programming content. And you can find my open source stuff at my GitHub. So just a quick run through of the agenda. I want to talk about the problem with TypeScript, qualities of production software, why my team is betting on effect, the power of an error, our TLD metadata service that we built with effect, takeaways in the future, and if we have time, I have an appendix of just some useful patterns that my team has found useful. One thing with effect is that because it is like this standard library, in fact, I kind of compare it to like Go standard library, which is very featureful and you generally don't need to reach for third-party packages. Effect is the same way. So there is like not a lot of, one, it's young, but two, because it gives you so much out of the box, you don't generally have to go reaching for packages to install. And that then turns into there's less open source code out there to see to use as examples. So including this appendix is kind of my way of like contributing that kind of those patterns back out. These slides will be on my GitHub. They're not quite up yet because I just finished them, but they will be right after this talk. So the problem with TypeScript, there's only one. Just kidding. So my hot take is that JavaScript has the lowest bar of entry to building and being productive, which I think is genuinely a good thing. It lets people get in the door to this industry. It lets them be productive. It lets them, you know, see what they're building more quickly and gets them hooked and keeps you building, right? I think that's a great thing, a great property of JS and TS. But I also think it has one of the highest bars of any language or stack or ecosystem to building high quality, stable, and reliable software. I also think that the biggest problem with TypeScript and Node backends in particular is that the language makes it far too easy to only ever consider the happy path. And I kind of really want to focus in on the happy path here. If you've watched me on Twitch, if you watched my conference talk at the last RVA.js, I think that considering the unhappy path in software is incredibly important and is one of the key pieces to building reliable software. So I think TypeScript has this problem called happy path blindness, which essentially my take on that is that it promotes a style of programming where it's far too easy to just write only the happy path and go on your way and never consider the ways our software can fail, right? So if you look at this function, which is fetch domain by name for user, this is a pretty innocent looking piece of code. I am positive all of us have written code like this and probably have hundreds of functions like this in your own code bases. If we take a look at what it's doing here, we're going to accept a domain name and a user ID. We're going to return a promise with the domain. First thing we're going to do is auth checks. And this user query domains, right? If that passes, all good. We're going to go to the database and we're going to query the actual domain. It's not found. We're going to throw an error and then return the error out. But there's a lot of things that can go wrong in these few lines of code. What happens if auth check throws? Can it even throw? If it does throw, can it throw them more than one kind of error? Do we need to react differently to these different kinds of errors? What about DB query? Same thing. Will this return null if it's not found? Is it going to throw? What happens if the connection goes down? What if we get rate limited? Are we able to retry on any of these errors, right? If the auth check fails, maybe the service is temporarily down, another node spinning up. Can we retry on that? We do have to retry. Do we need to consider like an exponential backoff, or can I only retry n number of times? Or maybe I have to pay attention to a rate limit header and slowly, dynamically retry. How should we communicate errors to our callers, and even more importantly, if it's going to be a customer-facing error, how do we communicate those errors, the things that can go wrong, to our users? Should we pass through the errors and just, as this code does, just ignore it altogether? Should we wrap them with our own errors, add more context from this function? So in this case, probably written by me, I'll just deal with the errors in the calling code. Me, 6 months ago, probably. So I take that code, my fetch domains by name for user function, I wire up a quick endpoint. Maybe this is for like a back office admin tool, right? Like it's not going to be customer facing. It doesn't matter. I just need to get domain data into this quick dashboard and I'm moving quickly, right? I haven't considered any of my errors so far. I know this code works safely for my use case. Catching the error at the route level and getting a 500 or something is totally fine. Also me, 6 months ago, probably. Then the new dev shows up. I need a function to fetch a domain. This looks useful. I'm sure it's safe to use, and whoever wrote it did it the right way. They import it into their code. Maybe this code is customer facing and in a hot path that ends up in Vercel's dashboard, right? And then over time, people continue to see this function and it just keeps getting imported across the entire code base. And deceivingly, under the covers, there's probably over a dozen different ways those couple lines of code could fail that now likely aren't being considered before they get to our user. So I know I said I was just kidding about only one problem with TypeScript, only kinda. So I have some other honorable mentions. The first one is that errors are typed as unknown. So when we use try catch in the catch block, that error type it always loses the type information. There is no type tracking there. In fact, like if I could get down on my hands and knees and begged Andres Heilberg and the TypeScript team to add one feature, it would be honestly like checked exceptions like Java style. Even though that is like not great and not fun, like the fact that we can't track the way our code fails at the type system level is one of the biggest problems, in my opinion, in TypeScript. So like in this example, let's say we have a function to get DNS records, right? And that get DNS records function can produce 3 different kinds of errors. We can have a DNS propagation delay error, or a DNS zone not found, or maybe we have an invalid zone error. And let's say that get DNS records throws that. In the code that gets called from, if I just even look at the hover docs for that in our code editor, like if I look at the type signature rather, I have no indication that function can throw. I have no idea that those 3 errors there can result from this. I have to go into the implementation and read the code myself to figure out that those errors are the things that can happen. And like, this is almost like recursive in nature too. Like, what if get DNS records has its own function calls? I suddenly have to keep going down the stack. I have to trust that whoever wrote get DNS records handled those errors down below. You can see how this just builds up over time, and we get into this state of unknown. We lose track of our errors. The next problem is function coloring. Does anyone know what function coloring is? 2? Okay. All right, this is going to be a fun lesson. So function coloring is a problem in programming languages that have asynchronous programming models, where when you introduce async code into your code, everything in that call stack also has to become asynchronous. So let's say I have function A, function B, and then I make a call to the database. That's 3 functions down the call stack. And because I did some async IO, now those functions above it suddenly became asynchronous. So we went from synchronous to asynchronous. Our programming model just shifted, and we have to account for that the whole way up the stack. So that's effectively function coloring. And I have a nice little example of what this looks like with a cartoon. So we have function A, function B, function C, function D, function E, and then async function F. Async function F puts their hand in the middle, and everything becomes async. Anthony Fu, who is the creator behind tools like Vitest and V, he works in the Vue core team. He recently published a blog post on function coloring and his own library called QuantSync, which essentially abstracts away the idea of asynchronous programming. It uses generators to effectively let you program against code and treat async or sync code paths identically. And Effect does the same thing. So what this looks like in his library is that you can take your function, in this case, we're reading from a file system, and you can declare the sync version, and you can declare the async version, and then you can basically have this generator function inside of QuantSync, and you can just yield read file. You don't have to think about whether it returns a promise. You don't have to think about whether it's synchronous. It doesn't matter. It takes that away from you, and just being able to think synchronously, even with async code, is a huge power unlock. Languages like Haskell and OCaml and languages with algebraic effects, or even libraries in Scala, have implemented this using things like IO patterns or lazy computations to get away from having to like shift around these mental models and solving the function coloring problem. So TypeScript and JS also have a fragmented ecosystem. I should add, we also have one of the richest ecosystems. It is very common, or probably I'd say 50% of all JS conference talks probably have a joke about node modules somewhere, or just npm installing it right. That's great, but it also has trade-offs. We don't have our version of Rails or Laravel or Spring Boot or one of these things that kind of puts guide rails up and like, this is the blessed way to build, backend software. And because of that, we end up monkey patching together, dozens and dozens of dependencies, or trying to write these complicated things in-house. All of these libraries and packages are written by different authors and communities and companies, and they are not built with each other in mind. There is like no shared design goals other than what the author of that particular package wanted. In large code bases, this can result in reinventing the wheel many times over, and generally poorly, because there are a million edge cases. Consider like exponential backoff for retries, right? I know in Vercel's code base, we probably have 3 or 4 different implementations across we have 2 really giant TypeScript monorepos, like hundreds of thousands, if not millions of lines of TypeScript. And having different implementations that probably all have their own little gotcha in some way, implemented incorrectly, is just, that's confusing. It's hard to figure out what's right. What is the one that's up to date? Which one should I use? Oh, this failed. So that is definitely a trade-off of our ecosystem. And because of that, if you are building large distributed systems in TypeScript and Node, you're probably going to be using a handful of Cinder sources packages. I don't know how Cinder does it, but he is carrying the entire ecosystem for Node in his backpack. Tools like plimit, pfi, pmap, pretry, pthrottle, pq, all these things for doing current asynchronous programming in Node is basically held up by this like just ecosystem of separate packages. So the next thing I want to talk about is qualities of production software, or at least what I think are qualities of good production software. So first, I think good software should be predictable. I think it should be observable. I think it should be refactorable, and probably more importantly, it should be easy to delete code. I think it should be testable. I think it should also be intuitive. And finally, I think it should be scalable. Now, I want to go back and revisit each of these and kind of dive into each of them. So first, predictable. So when I say predictable, I mean that our software operates in a consistent way. We know how our software can fail based on our error handling. Like I want to know in every single way that my software can fail generally, like, right? I want to know how my software is going to recover when it does hit these errors. That kind of plays into the next point, which is observability, right? Like when you're dealing with software that has, even just like back office software, this is so important. Like being able to easily debug your code and see what's going on at runtime with logging metrics and traces is crucial. And having good error handling and the predictability of the first point makes the second point so much easier. You get paged at 2 in the morning from like an elevated 500s occurring on one of your endpoints. Like you want to be able to dive into those traces quickly, see exactly what error is happening and where, and go fix it quickly. You don't want to be in the dark trying to do that at 2 in the morning. I promise that is not fun. I think it should be refactorable. I want code to be easy to add features. I want it to be easy to read existing code. And I also want it to be easy to make modifications without fear of how I impact other parts of the systems, especially working in these giant TypeScript monorepos. Like what happens if I edit that function we saw earlier, the fetch domain by name? Like, is that gonna suddenly break some caller, like, the whole way across the other monorepo? I have no idea, right? Because maybe tests catch that, maybe. We can't really rely on our tape system, right? Because we're not tracking errors the whole way across. I also want it to be testable, right? And I don't just want like tests. I want meaningful tests. I've seen across my career lots of TypeScript code bases that have a ton of test coverage. But a lot of the time, those tests are borderline worthless, especially when you're using something like Jest's auto mock feature, where we're mocking dependencies based on import paths or resolution paths. Like it really turns into a world where you really end up testing not only the implementation details of your code, but you're really just testing your ability to write good mocks. And over time, when you develop big test suites like that, it like becomes a chore to manage and write tests. Like, I don't want to have to go change hundreds of lines of code when I change or add maybe publishing a metric event in the middle of my function. Like that should not be a thing I should have to worry about when I'm writing tests. I want the code to be intuitive and more exact. I want developers to be guided to doing the right thing. Like I want the abstractions, the library, and the code in our code base to really guide my team to doing the right thing. Like I want to make the happy path for them that also considers the unhappy path. And I want it to be scalable. And in particular, I want it to be scalable at an organizational level. I think TypeScript scales perfectly fine. I think TypeScript and Node is a great solution for backend services, especially ones that are kind of more focused for web dev or are IO bound. That being said, I think that TypeScript doesn't scale at the organization very effectively. And what I mean by that is, like, as you grow your code base and grow the number of engineers you have and the number of packages and the number of services, I want it to be relatively easy. Like, that's not going to be easy in any language, but I want it to be as easy as possible to keep up and maintain large amounts of code in an ecosystem. So these traits and properties and qualities are deceivingly hard to achieve in TypeScript, especially as code bases and engineering orgs scale. And in TypeScript in particular, to scale TypeScript and maintain those qualities, it takes a lot of discipline. It takes discipline when you're authoring code. It takes discipline when you're reviewing other people's code. It takes discipline when you get paged at 2 in the morning and submitting patches. And unfortunately, discipline on its own does not scale. So just to, why should you listen to me about what I think is important in production software? I've had the fortunate positions in my career. I've got to work at, obviously, Vercel. I get to work with brilliant devs there. I formerly worked at a company called Formidable Labs. And in both places, I've worked with members of the React core team. I've worked with the Next team. I've worked with early GraphQL people. And I also did consulting for 6.5 years. And in consulting, you're getting dropped into different companies, different engineering orgs, different code bases every couple of months, right? And you have to come up to speed on all these things. And you just get to see a wide breadth of how different companies are managing these code bases and these problems. So I've worked with dozens of Fortune 500s, early stage startups, and even FANGs. And like across the board, regardless of organization or team size, the skill level of the engineers there, or the types of product being built, I have not seen TypeScript scale in a maintainable way at the people and process level. And I personally even feel that's true at Vercel. Like, our giant monorepos are very, very hard to manage all of our dependencies and track errors and reliably do tracing consistently. It just doesn't scale. So that's where effect enters. So why my team is betting on effect. The too long didn't read is it makes doing those hard, tedious, and error-prone tasks that require discipline easy, natural, first class, and fun. So up first, effect is predictable. So I know many of you are not familiar with effect yet, but this is like the core type. If you take nothing else away from this, learning what this type is makes everything else easy to reason about. So the first generic parameter in this type, A, is our success channel. This is the success type. Every effectful function or computation returns an effect, right? An effect will always have this A, this E, and this R. So we can always see what our effect will return to us if it's successful. The next parameter is the error channel. So effect is going to track errors for us as we encounter them. So now we can look at an effect and we can see how it's going to succeed and how it's going to fail. The final generic parameter is the requirements channel. And this is where dependency injection comes in. As you're using effects and composing them together, and let's say I'm writing functions where I'm importing a database and maybe some metric thing. As I do those, effect is smart enough to track what you're using and put it into this generic parameter for you, and you won't be able to run your program until you provide implementations for those dependencies. And we'll get into that here shortly. So just by looking at this one type, right? The effect type can inform us of all the guarantees and constraints of our programs at just a glance. Like this is what I want when I'm looking at a function in a code base that I don't know. I want to look at the type signature. I want to know what's going to give me. I want to know how it fails. I want to know what I need to run it. So for an example from our code base, we have this upstream registrar service, right? One of the functions on it is get price. This basically goes to our upstream registrar partner and says, give me the price for a domain. So we pass it a domain, we pass it some options, and it's going to return us this effect type that has a get price response, which I don't have here, but you can imagine it has the domain name, the price, if it's available, whether it's premium, etc. And it can also return an unexpected upstream registrar error or a more specific execute API command error. And then the dependency to run this effect is I need to provide it a register or the client to issue API requests. So just looking at this, I know exactly how this code will run. I know how it will fail, and I know the things I need to run it. The next thing, and probably the most important thing to me, is composable and typed error tracking. So let's say we have these three functions in our code base. Query domain takes a domain name, returns an effect, where if it succeeds, we get a domain. If it fails, we get a domain not found error. Then we have an enriched domain. That takes a domain type, and it returns an enriched domain. And if it fails, we get an enrichment error. The final is renew domain. That takes an enriched domain and returns a renewed domain or renewal failure. If we were to use these all together, I should back up. Let's talk about the generator syntax quick. I know that's going to be kind of weird. I know that's kind of a knee-jerk reaction generally to people. So I already kind of showed the QuantSync library earlier from Anthony Fu. So to address the elephant in the room, you can read yield star almost identically as a wait. Just in your head, replace yield star with a wait, and it's going to do essentially the same thing. So when we yield star query domain, it's going to either give us the domain or immediately return from the scope or the function with the error. So if we hit an error on query domain, what's that did? If we hit an error on query domain, we stop the computation, immediately return with the query domain error. Then we call enrich domain, same deal. We call enrich domain. If it succeeds, we get the enrich. And finally, renew. And then we return the renewed domain out. Question?
Stupid question.
Yes.
What is the star behind the function called?
That is just how you do a generator function. That's the standard ES6 syntax for that. Basically, effect.gen lets you write effect in like this imperative style that we're used to with like async await. You can also use like what they call the pipe API, which looks more like functional programming, or like if you chain on a promise like dot then, dot then, dot then, dot then. You can do the same thing with effect rather than using this generator syntax. I just think this kind of imperative style is easier and way more familiar once you get over the knee-jerk reaction of yield star. So given this last slide, does anyone have any idea what the function signature for renew domain handler would be? Yeah.
It would return a renewed domain. The second thing would be all three of those errors work together. I don't know what the third will be.
Yes, exactly. If we were to pull up the type signature in our editor, we would see that renew domain action is a function that takes a domain name and returns an effect where the success is a renewed domain or a union of the three errors that occurred in the computation. And effects type system did that for us. It tracked it for us, and you can kind of start to see how, like, as you compose these different effects together, it does all of this tracking for you. The next thing is dependency injection. Dependency injection is somewhat uncommon in the Node in JavaScript ecosystem, and it's also why we lead to like what I think is pretty poor tests on average across the board. And like the solutions that are out there for dependency injection in Node are quite frankly not great. Like I've used a bunch of them. Like I've used Nest.js for it, and that does okay, but it like feels a lot like Spring Boot, and there's like these configuration files that you have to wire up, and it's just like, it's not intuitive, it doesn't feel good to use, and it just gets in the way more than anything. So I was incredibly skeptical of effects dependency injection when I first started playing around with it, and it has grown on me to probably be one of my favorite parts of effect. And it's probably the most novel and ergonomic form of dependency injection I've seen across any language. So dependency injection ties into the requirements type of the channel, right? That's telling us what we need to provide to an effect before it can run. So if we look at this function, process upstream registrar TLD, takes a TLD name. Anyone that doesn't know what a TLD is, top level domain, it's gonna be like .com, .dev, .app, .ai. We're going to, okay, I'm gonna have to explain this too. So you'll see here where I yield star upstream registrar, right? What this is doing is upstream registrar, domains registry, ElectroDB, and price caching these instances are these classes that we call tags. We'll cover tags in a moment, but effectively we're saying, hey, effect runtime, give me your known implementation of the upstream registrar client. I don't care what the implementation is. I don't care if it's a mock implementation. I don't care if it's an in-memory implementation. I don't care. Just give me the implementation you have in your runtime right now. And it knows the type here. So if I have a nice, beautiful interface for my upstream registrar client, when I yield star that, the registrar, that object or class that I get back is going to have all the functions and the types on it. So we go through and we get our registrar client, our database client, and our price cache client from the context. We can then use that on the next line, right? Registrar.tld's.get TLD metadata. And then we can essentially persist that data to both the database and our price cache, right? So this effect ends up looking like it returns nothing. So if you look in the previous line, we don't return anything here. So it's going to return void, or it's going to succeed with void. There is an error that can occur. And in this code, this persist upstream TLD error is actually just a type alias for a union of other errors that can occur to make just reading it easier. And then we see that we have this union type in that third generic parameter here, our requirements. Effect automatically appended upstream registrar as a requirement, our ElectroDB client as a dependency, and our price cache as a dependency. And what this looks like to actually run this code, let's say we have this other function, process TLDs, and we want to call our function, process upstream registry TLD. Very wordy, I'm realizing every time I speak this out loud. When we yield that, if we were to try to run this, which there's an API like effect.runPromise, effect.runSync, effect.runPromiseExit, there's a bunch of ways to run effects. There's a whole API for it. But if we were to try to run that without providing implementations for all of the dependencies, we're going to get a type error. Our program won't start. It's going to be like, hey, you still have dependencies here that you haven't given me. So what this looks like is we can say we have this production dependencies, and we do this thing called a layer. So we end up providing the upstream registrar default implementation that could just as easily be upstream registrar.production. We provide a default implementation for the ElectroDB, and we provide our default implementation for price cache. If you were to look at what the implementations of like .default are on each of these are setting up and bootstrapping the actual production implementations, reading in environment variables, doing whatever else you need to bootstrap the clients, right? And then we just provide that layer to our effect. And I don't think I have a slide on this, and it's something I should add. But as you provide dependencies, it removes them from the type union in the requirement slot. So for your effect to run, you need to get the requirements channel to never. If your requirements is never, that means you provided the effect all the dependencies it needs. So if I want to test this, I just make a test layer. And this is test dependencies, and I'll provide the test implementation for upstream registrar. Maybe I want to use local stack for testing ElectroDB, which is really a client around DynamoDB. And maybe the price cache, I want to use an in-memory version rather than Redis. So you can see like how I could basically compose together this nice test dependencies layer, and I can use that in my test now. And I just don't have to think about all this dependency injection and mocking paths and all this stuff. You can also do things like change implementations at runtime. So one thing we're experimenting with right now at Vercel is our registrar partner has a test environment similar to Stripe does. And when we turn on a feature flag, that essentially is going to tell the backend when requests come in for a user that has that feature flag on, they see that. For the scope of that request, switch the implementation of our upstream registrar client with the test implementation rather than the production implementation, and that will hit our test environment. So you might be asking like, well, what's a layer? And that is basically a subtype of an effect. This should look almost identical except for that first layer, right? So the dependency. It's dependency rather than success, right? We still have the error, we have the requirements. Layers are how we create implementations of our dependencies to provide to effects. Yeah, it's the private, of course, I got ahead of myself. So what does this look like at runtime, right? We talked about how there's this kind of like context that when you yield one of these, that you get it out. And what this really looks like is this type here, where basically type context, and it's kind of like a record where the key is a tag, and the implementation or the value is an implementation for the service. And if we were to refer back to the other code, what this could look like, right, for the price cache, the key is the price cache tag, and then the value is the default implementation. But maybe in test, this actually looks like still the price cache tag, right? And then we have the in-memory implementation. Yeah, so it's just nice to be able to, you can even get away with writing a bunch of code and types without ever writing an implementation. Maybe you just want to like feel out a pattern or a code path or a design. You can write your types, make your tags, and then just yield things, and then come back later if it feels good and operates how you want to, and then provide the implementations. And really, you can just yield star things. So the next important part is observability. Effect has observability baked in by default with OpenTelemetry. You can basically just pipe effect.withSpan, give it a span name, add some attributes or annotations, and set up a layer for your OpenTelemetry collector. Done. It's literally that easy. I don't know if anyone has experience setting up OpenTelemetry in other code bases, but it can be a nightmare to get working correctly. And just having that out of the box, this is like an example of like where it just like naturally guides someone to do the right thing, right? Like you don't have to think about it. So of course developers are going to do it because it doesn't take a lot of work. It's like a couple extra lines of code and suddenly they get all their data in Datadog or Jaeger or whatever you're using for your tracing, right? And yeah, this is just an example of what traces look like if anyone hasn't worked with OTel before. Next up is something that I heard on the official Effect podcast in the most recent episode, Harmony. The guest on Cause and Effect was Michael Fester, and he is a founder of a company called MarkPrompt, which is a AI company for doing like customer support. It's actually really great. We use them at Vercel. You can look into MarkPrompt at your own time, but highly recommend checking it out. But MarkPrompt is built entirely on Effect. And when in this podcast episode, when Michael's talking about like betting on Effect at MarkPrompt, he refers to it as like being harmonic or harmonious. And that really resonated with me because like everything within Effect just composes together, works together. It doesn't take a lot of work to do anything in Effect. Like if you can learn what effects and layers are and maybe 2 or 3 other patterns and types, you can be incredibly productive, incredibly quickly. They have a schema library or runtime type checking library like Zog called Schema that just composes together with everything. Like it really does feel like building with Legos. So to dive more deeply into what it was like to adopt Effect on the domains team. So the initial timeline was in December, we wanted to write self-serve renewals. January, start building our TLD metadata services. February, start working on our search by revamp. And then in March, give a comp talk. Now the actual timeline. December, started self-serve renewals. Got kind of off track because of a urgent request and need from our billing and money team, and had to refactor our availability and buy APIs. In February, we did get self-serve renewal shipped, and the domains team actually became official. We got 2 more engineers and a full-time designer on the team. And we recently just shipped our TLD metadata service, which we'll talk about here shortly. And we just had our kickoff for revamping search by. I was hoping to show up here and be like, check out all this sweet services that I built with Effect and all this awesome data to support my use case. But unfortunately, I don't have that at the moment. But we have managed to adopt it for pieces of our services. Yeah, timelines, am I right? We all get it. So the power of an error. We launched self-serve domain renewals, I believe in November. And up until that point, Vercel historically only supported auto renewals on domains if you bought through us. The domains product area had the second highest amount of CSE tickets month over month, and a majority of those resulting from errors from our basically auto renewal cron job. I should also add that domains is one of Vercel's oldest products. It's never had an official team on it, and it's kind of operated under this model of shared ownership, which after a certain size basically means no ownership. So you can kind of see how we got there. It's funny, like domains has some of the only plain JavaScript code left in the code base. And like when I first started on the domains team, I was in one of those JavaScript files, and like the git blame was literally Guillermo from like 7.5 years ago. So at the time when we first started working on self-serve renewals and breaking out some of that renewal logic from the cron job to put in API endpoints to enable customers to renew basically on their own timeline, we had 3 errors that can come from that. We had an API error, which is strange because it was not an API. We had a straight payment error, and we had a straight payment method error not found. And we also had very little logging and no telemetry. So enter data.tagged error. This was the first piece of Effect that we used. And the data library and in Effect does not require you to use effects. It's a bunch of utility functions that work with plain JavaScript. It has stuff for like pattern matching. It has stuff for date time. Like I said, it has basically everything you would need to breach for other NPM packages. So in particularly, we started with data.tagged error. So what does this look like? So let's say we have this domains mutex error, and it extends a tagged error. We give it a type name, kind of looks like if you were making, not that dissimilar from making your own custom error. And if we create a new instance of that, we'll see that we have this underscore tag property on it. And if you've worked in TypeScript long enough, you'll probably know what a discriminated union is. Basically, a bunch of types that are unioned together and then have some property that they share across every instance of that type that discriminated. So you can imagine we have a bunch of these tagged errors. One might be, error A, error B, and domains mutex. The tags will let us, let's say in a switch statement or an if statement, if we switch on the tag, it's going to give us autocomplete for the various names. And if we narrow it, we'll have the type of that error. Let's say, like the domains mutex error has this domain name on it. Maybe another error has like the customer ID. Once we narrow based on that tag, we get access to that data. So as part of extracting our renewal code from the auto renewal cron, we audited our errors and introduced neverthrow, which is a library that brings basically Rust result type into TypeScript. We weren't quite ready to go all in on Effect at this point, and we were using neverthrow in other parts of our code base to basically do typed error tracking. Once we did that, it resulted in a dramatic reduction in CSE tickets. It empowered customers to, renew domains on their own time. And, if they encountered these errors, we gave them messages, more meaningful messages about what to do, how they could help themselves, if it was recoverable, if they had to worry about it. So after we did this audit, that same code went from 3 errors to 17, each with its own context, user-facing error messages, internal error messages for logging and telemetry, and retriability constraints. And this is actually the error, all the errors that can come from our renewal process. Can't renew, customer ID not found, going through this list, each of these, some of them might be okay to ignore if they happen. Some of those we might want to pass to the calling function. Some of those might require the user to reach out to customer support. Some of those we might be able to retry over and over again. Some of them might require a refund to the customer. So basically getting granular on our errors like this let us build so much more resilient software. And this is a great tweet that came from Wix Engineering probably a year or two ago. And like I live by this, like in code review, error messages internally and customer facing, I try to get them to this point. So say what happened, provide reassurance, say why it happened, give them a way out and help them fix it. This like just, if you do nothing else, get granular with your errors and really focus on providing good error messages for both your developers and your customers. So the TLD metadata services. This is the first service that was written completely in effect on the domains team. So the problem, our TLD portfolio, their metadata and their prices were all managed via private internal NPM package and various one-off JSON files. Making changes required publishing the NPM package and redeploying dozens of services across both our front-end monorepo and our back-end monorepo. Metadata and pricing was scraped and derived from a combination of an Excel spreadsheet, often with human-based data entry errors, and support web pages from our upstream registrar partner. So you can see how error-prone of a process this was. So I'm not going to go over the full architecture here, but the long story short is it's a service that twice a day syncs with an API from our registrar partner and syncs the metadata and prices. The TLD data is processed, transformed, and enriched, and then finally stored in DynamoDB and into Redis for quick lookup on pricing. TLD registries, you'll find out if you ever work in domains, are very inconsistent, especially country code TLDs, and unreliable and tend to be error prone. Effect allows us to handle these failures basically with like surgical precision. Like if the .ai TLD, which is run by the country of Anguilla, which is a tiny island with like one dude living on it, fails, like we need to be able to handle that and not fail the entire sync process, right? We had to build it in such a way that this network IO heavy service would also not impact our rate limits for all our other services communicating with our upstream registrar partner, right? Like this is a net new service and we're not taking down anything else, but we still have to bear in mind our rate limit to our providers. So Effect basically let us handle all of these edge cases with incredibly low amounts of code. Like I really wanted to come to this with like an example of like, here's the effect code of our sync process. And here is it replicated in, just TypeScript with other dependencies. And like, there's probably 4 to 5 times more code with the default, just like TypeScript implementation using things like Cinder sources packages. So takeaways in the future. So let's talk about the good parts of adopting Effect. It answers the most common problems we have at Vercel and our TypeScript monorepos. That is consistency, knowing what to reach for, handling errors, telemetry. It lets us, I've said this a bunch of times, but like genuinely, I cannot emphasize this enough. If you take the time to play with Effect and get over the small little hump, everything starts looking the same. Like everybody's Effect code looks identical. Like I said, it puts the guardrails on for you to do the right thing, and all Effect code ends up looking super similar, and it drives you towards making abstractions that are very tiny because it's so composable. So like, I want to compose together my price cache with my DynamoDB client and with this and that, and it all just goes together. So the smaller you make your units of code, the greater composability you get, and it just becomes plug and play. And you end up being able to move very, very quickly because you can just yield star things. It's easier to maintain, refactor, and I speculate, possibly unintuitively, because it is unlike anything else we have in TypeScript, that it's going to make the onboarding process and being productive easier. And in the Mark Prompt episode of the Effect podcast, this is talked about a little bit. They're hiring a bunch of Python ML engineers, and they are able to come up to speed, even though they've never worked in TypeScript in their life, incredibly quickly, because they have all these examples of effect code. They see all their tags and dependencies they can use in the code, and they can just yield start, get it, and go on their way. And it's tracked, and it's, yeah. So I have not hired someone to my team yet to test this theory, but hopefully next year I'll be back to talk about that experience. And then also the open telemetry integration is just hands down amazing. It does not get better than Effect. And Schema is also chef kiss. That's the runtime type checking library or part of Effect that is like Zod or Archetype or whatever else, Malabot. I was initially incredibly skeptical of Schema. I didn't really like it at first. It's like, I know Zod, I can be fast with Zod. And then we started using Schema a little bit more. For example, you can define, like in their HTTP packages, you can define a schema for your REST services, and you can generate open API specs from it. Schema is unlike anything else in the TypeScript ecosystem when it comes to these kind of runtime type checking things, because it cares about both encoding and decoding. In JavaScript, we almost always only think about decoding, right? We get some string across the wire, we decode it from JSON to an object. With Schema, you can think about it both ways. That enables things like, maybe you want to go back and forth between prototypes, or maybe you want to go back and forth between a persisted domain and the domain type entity you want to use in your business application code, and then you want to encode that to a more optimal wire transport protocol than JSON. Maybe we want to transfer binary across the wire. It lets you do all of that like super simply, and it's just composable as the rest of the ecosystem. So not everything is rainbows and unicorns, despite me wishing it was. Buy-in can be challenging due to the perceived learning curve. I think people can look at effect code, and because it doesn't look like anything else in TypeScript, get the knee-jerk reaction that there's this giant learning curve and I'm not going to be able to be productive for some great amount of time, and it's going to be hard to onboard people, and it's going to make these weird one-off patterns, and it's going to fracture the code base. In reality, Effect is super easy to incrementally adopt in your code base. You can just like kind of branch off one little part of your, if you think of your program as a tree, you can start at the leaves, just put an effect.run promise, and everything under that can be effect. And it's just as easy to convert an effect back to a promise the other way. You can end up using your effect code in your coworker's async promise-based code. Getting OTel to play nice with Datadog and integrate with our existing tracing was challenging, though this was largely Vercel specific because of the way we set up Datadog. I would not anticipate this being a huge problem for kind of more standard Datadog setups. There is a large API surface. It is TypeScript's missing standard library after all. And when APIs weren't documented, we had to rely on the effect team or going to their Discord. And at the moment, AI also doesn't have good knowledge, one, because it's so new, and because if you were to generate like an AI-friendly text file for the API, it is generally going to exceed the context window for most AI right now. Although I have it on good, I don't know what the phrase is here, but I believe next week at Effect Days, they're going to be announcing a some solution for AI docs and stuff on their main website. And even from release, like this team really, really does care about doing it right. And like if you looked at like the quality of the docs release day last year in April to today, it is just, you can see the care and love and passion they put into this stuff. And it makes me really optimistic about the direction it's going to go. Some feedback I've gotten from other team members at Vercel is sometimes some of the APIs and abstractions feel too low level, like there should probably be something above it, or it should be namespaced lower. and aren't as intuitive as the rest of the ecosystem. Like I kind of mentioned already, if you like pay the cost of just learning how effects and layers work and getting like 5 or 6 of the top level APIs down, you can be super productive very, very quickly. There are just some things that don't work as you would expect sometimes, and because the documentation is not perfect yet, you sometimes have to go digging. But looking to the future, I'm very excited, eager, and optimistic about the future of Effect, especially at Vercel. We're exploring using Effect Cluster, which is effectively a port of Erlang's OTP runtime to TypeScript, which is super, super exciting for our domain and cert renewal pipelines. We're hoping to start internal lunch and learns and advocating more broadly inside Vercel. There's a couple other teams that are already exploring Effect internally, which is kind of cool because like when I started talking about Effect a year ago, like it was the knee-jerk reaction from a lot of people that like, oh, this is weird, like we shouldn't introduce this is going to splinter things. And now more and more teams are seeing the value and that it can actually answer the problems in giant TypeScript mono repos. And our revamped search by and registrar services will be powered entirely by Effect, which is hopefully coming soon. Thank you. I'll upload this later. I'm not going to run through this now, but there's a bunch of useful patterns that we found in here that we've used that might be good reference. Thanks, y'all. Appreciate it.